Given the radical function f of x equals the square root of 4 minus x, find part A, the domain of this function, part B, the graph, but just use points to do the graph, and part C, the range of this function. Okay, it's going to be easy to do the range after we have the graph because we could just look at the picture. But let's continue here. Solution. First we notice that we have, for part A, we have a requirement the radicand be greater than or equal to 0, and that's because the index, the invisible 2 in the little hook, is even. Okay, so what does it mean for the radicand to be greater than or equal to 0? It means that 4 minus x has to be greater than or equal to 0. That's the radicand, the stuff under the radical sign. All right, solve this inequality by getting x alone on the left side. Let's see, we'll move the 4 to the other side. Negative x is greater than or equal to negative 4. And then we get rid of the negative sign by dividing both sides by negative 1. But when we do that, we are required to flip the direction of the inequality sign. Remember, whenever you multiply or divide both sides of an inequality by a negative number, you have to flip the direction of the inequality sign. So this, on the left side, negative over negative becomes x less than or equal to positive 4. Okay, so let's write that. Let's see, that means the domain is equal to, well, let's do a graph. Let's shade everything to the left of 4 and put a boxy bracket on it. Let's now express that graph in interval notation. Open interval from the smallest value, negative infinity, comma, to the largest value, shaded 4, with a boxy bracket to include the 4. Okay, that was the domain. Now let's work on doing the graph by using points. The basic graph for any function h of x equals the square root of x, it looks like this picture. There's a point at the origin, and it's a little swath that moves out to the right. There's nothing on the left, and it includes the point 1, 1. This is the basic y equals square root of x function. So we know it's going to be some variation of that. But they told us just to use points, so okay, we'll just use points and see what the thing looks like. All right, so f of x equals the square root of 4 minus x will be similar to that graph. Okay, so we're going to choose x values in the domain from negative infinity up to 4, including 4. We could choose 4 also. And we were going to choose values that give us a nice perfect square, x values that are perfect squares, or that give us perfect squares when we put them under the radical sign. Then it'll be easy to figure out what the square root is. So what number can I choose on the interval from negative infinity to 4 that I could plug into 4 minus x that would give me a perfect square? Well, I think the first one I'll choose is, well, let's make a table. X values and the y values will be the square root of 4 minus x. That'll give us ordered pairs. Okay, so I'm going to insert a 4. A 4 is a good number because that's going to give me a perfect square under the radical sign. So y is then equal to the square root of 4 minus 4, which is the square root of 0, which is 0. Okay, so when x is equal to 4, y is equal to 0. For the next value, I'm choosing x equals 0 because when I plug that in, that's going to give me a nice perfect square under the radical sign. The square root of 4 minus 0 is equal to the square root of 4. And what is the square root of 4? It's positive 2. So we just found the ordered pair xy equals 0, 2. And finally, I'm going to choose, let's see, on the interval from negative infinity to positive 4, and the next value I should choose should be a negative 5. Now look what happens. The square root of 4 minus a negative 5. Well, what's minus a negative 5? Double negative. That makes it plus. So it's 4 plus 5. So that makes it the square root of 9. See, 9's a perfect square. The square root of 9 is 3. So that gives me the ordered pair xy equals negative 5, positive 3. Okay, so let's do a sketch and see what this looks like. Now you'll notice that the x equals 4 is the largest x value possible in that domain. There's no larger x values. Okay, so keep that in mind. Here's our y-axis, and here is our x-axis. We'll put a few numbers on them. Let's see, I'll just go out to 4, 3 or 4. Go out here. Here I have a negative 5x value, so I'll go out that far. I'll go up on the y-axis to 3. Go down a few steps here. Okay, we'll graph our first point, 4, 0. There it is, 4, 0. And then our next point, 0 and then up to 2. And then our last point is negative 5, 3 up here. Now it should be a smooth curve, and it looks very much like the picture I first drew. It's just turned the other direction and stretched out, but it looks a lot like that. Yeah, I'm believing that. Okay, now, part C is where they ask us to do the range of this function. Now, range are all possible y values, and you can look at this picture and see there are no points on this graph that have y values smaller than 0. But they do have one that's equal to 0. That's the ordered pair of 4, 0. You can see that point. And all the values of y, I'm talking about y values, above the x-axis, all the positive values of y, will eventually be a point in this graph because it's growing taller on the left side. It's taller and taller and taller. That means that the range is the interval notation for the y values, everything from 0, including the 0 with a boxy bracket, to infinity with a round bracket. And you can see the sketch and see that's exactly what's happening with our y values. That's our range.